Thank you very much. And I think there will be good synergy. And people were asking, asking about the semantics of conversions in the context of catalog federation, and actually, it works well together. So that's an excellent segue. So I'm Dennis Wu. I'm a software engineer at Snowflake. I've been working on catalog federation in Apache Polaris. Apache Polaris is an open source implementation of Iceberg REST catalog with productionization in mind, and which supports things like RBAC and caching policies, things like that. So for this presentation, we'll be going through an overview of what federation is. Even if you're just coming in not knowing anything about federation, we'll talk a little bit about that. We'll talk about some generalized concepts that we want to apply more broadly, even beyond necessarily the Polaris Catalog Federation project, but which are applicable to other similar scenarios. And then we'll sort of deep dive into the anatomy of how this works in Polaris, the current state of things, what we have and how we're thinking, and then we'll do a demo. So to overview catalog federation, the most basic formulation of federation is simply that your catalog, your local catalog, can serve as a pane of glass into any other remote catalog. So a very simple concept at its core. Where it gets interesting is when we have things like different implementations of catalogs, different flavors of remote catalogs, different formats even, right? So when we start talking about combining format conversions along with request conversions and request transformations, where a remote catalog might not speak the same language as your local catalog, for example, but then you'll want to have client libraries which can, again, go through that single pane of glass and not have to know whether they're talking to a remote catalog or a local catalog. They don't have to know, different protocols. They can just talk to one place. And in particular, if other catalogs don't serve the same set of features, then a federation layer is an opportunity to add in those kinds of things like authentication, authorization, caching, and other features like that. And one thing we also notice is there's a really broad range of use cases for federation. So often when people start talking about federation, they're actually talking about a lot of semi-related potential use cases. And sometimes this gets lost when we use only just terminology that talks about things in terms of generalized federation. But there's really a lot of related concepts. And we've seen use cases where, for example, federation is a solution to being able to unify your data lakes that have organically grown with lots of disparate projects, right? Like projects pop up, acquisitions happen, skunkworks projects turn from maybe like an intern project into something that lands itself in production. And this is something that always happens. This is something that really identifies the data lake historical DNA really of the data lake, right? Things pop up, and you have all these organically grown catalogs, and organically grown groceries might be healthy, but not so healthy for your data lake, right? So federation would be a way to bring a little bit of order to that. We also see it come up in peripherally related use cases related to failover, for example, replication. When we talk about tooling that can create copies, read-only copies maybe of catalogs or backup copies, often things that start looking a lot like federation also come into play. In some cases, people just want to migrate off some legacy Hive catalog. Sometimes you want to add some functionality on top of these legacy catalogs. Maybe for the long term, maybe you're not migrating, but you still need to slap some RBAC layer on top of that and things like that. So that's part of why we want to talk about a very general model initially, right? Regardless of what we're trying to tackle initially in Apache Polaris, we want to have sort of a generalized model where we can at least reason about constructs in a common terminology. So first, one of the things we'll talk about is this idea of just-in-time actions, which I'm sure it's not a completely new concept, but in this case, we're talking about in a situation where a local catalog might have functionality which depends on a certain amount, certain prerequisite local state, or certain assumptions about local state. The idea being that with just-in-time actions, like just-in-time creation, we want to take away the burden from the user of having to think about setting up that local state preemptively and just seeing how far can we go by deducing the prerequisite local state without that intervention. And in this way, we can have things that feel like really hands-off federation, and yet we can still get the benefits of features that might need local state. And I know that this might sound kind of abstract. That's by design. As we go into the demo, we'll see like how that applies concretely to actual features. Similarly, with just-in-time refresh, if there's an implication that there's some amount of local state that is sort of functional, that is stateful, that represents that remote state, to be able to define what it means to efficiently be able to refresh that just in time, as we're serving the request, but again, without that user intervention. So another thing that we've seen is just introducing some amount of terminology, some of which may or may not already be standard, but at least the concepts we see popping up time and again is, we'll say, if we're talking about a catalog being the source of truth for something, that means that subject that catalog that we're talking about is just the primary source of truth. It's pretty straightforward. It holds, the state of the world for that entity. And generally that means that's also what's responsible for coordinating updates, like coordinating transactions, commits, things like that. This idea of a facade is how we'll refer to entity representations in a local catalog that in some way reference that remote source of truth. So it could be a pointer to a remote source of truth. In some cases, that might be indeterminate as well. So like in the case of a static facade, so we have these two subtypes, static facade and pass-through facade. In a static facade, there's this idea where we might say, we might have a pointer that says that this piece of, this table, for this iceberg table, is externally owned. But we may or may not actually talk to that external owner. In this case, it's still, we see it as being related to federation in that even if that's abstract, this facade exists to have an abstract representation of that remote entity. So oftentimes we'll see this come up, for example, when you're talking about linking in an external table. So when you create an external table, at least, like let's say a traditional Hive external table, and it's read-only, what you're kind of saying is like, I just want to, you're stating that you have an entity, you have a facade, where you want this to be able to function by itself in Hive. You want to be able to read it. But you want to say, look, something else actually owns this. So don't screw around with it. Don't try to clean up orphan files. Don't try to accept updates or anything like that. And there's a couple other patterns we'll see that reflect this. In a pass-through facade, the idea would be we still want to have a local representation of this entity, but there's a pointer to that external source of truth that is always reflects the up-to-date state. So whenever we're serving a request, like loading a table, and let's say we have a pass-through facade, that means we do want to still load the table from the remote source. But we are going to store enough, we would still do have a facade in this case, right? We still have some entity representation. And this is somewhere in between the idea of just proxying requests through versus having something that functions by itself. And we'll see how that might that applies to things like migration scenarios, or even without migration, you might want to perform caching. So you could say like you have a pass-through facade, but you define some protocol where you can cache things and efficiently determine whether or not you need to do a just-in-time refresh. Finally, in the case of having an implicit entity, that just means that there won't be any local representation of that entity at all. Your requests are all passed through to the remote catalog, and you discover that entity at request serving time. So it's interesting that even outside of the world of Iceberg and Federation, we could compare, as an analogy, pass-through facades might feel like a file system symlink, right? You've created a symlink that points at a remote source of truth. So there exists an inode there that represents your symlink, and yet the contents are actually defined by the actual file. In an implicit case, when you mount an NFS directory, for example, you're not immediately sucking in all the inodes from the remote source. But as you try to access a file, you'll make those network calls to get the files. So now let's jump into a little bit more specifics. I know that was a little abstract. So looking at the anatomy of what it means to handle a catalog request. So some of this is a little specific to Polaris, but also I'm trying to use somewhat generalized terminology here. So at a high level, what does Polaris does? It's really just these four things. Polaris will figure out what are the identities and roles coming in with the request. It will figure out what are the securables that pertain to the request. It'll make a decision, an access control decision, to say yes or no, whether this thing is allowed. And then it'll execute the business logic, right? So just those four things: get the identities, get the securables, make an access control decision, and then do the thing. Like I mentioned, right, we want a general model that talks about all these different things in terms of federation, even if, typically we break out, federation to an identity provider is, typically a different thing from from federation to, catalog contents. And yet they are they are closely intertwined. So we'll sort of talk about how this pertains to all of those together. In Polaris specifically, there's sort of this upper layer. The upper layer principals, principal roles, and catalog roles form the foundation of that identity and role system and hierarchical roles. At the bottom, we have catalogs, namespaces, tables, views. These are the iceberg objects. We call these securables. And then in Polaris, the authorization policies are expressed as grants. So any of these links that you see in this graph that both are grants between from a role to a higher level role or a role to a principal. Those are grants just the same as grants for privileges on securables are to the catalog roles. So we have grants, we have these things, and the way that those four steps that I talked about happens is depicted here. There's an algorithm within Polaris where it'll fully resolve those identities and roles. It'll fully resolve the securables, and then it performs a big crunch to determine the authorization decision. And this is where it can get a little complicated with fine-grained privileges, but in the end, that's all it is. So let's see how that might apply to the model. So we introduced terminology, right? We talked about sources of truth, facades, and then we talked about these this hierarchy of identities, hierarchies of securables. So essentially what we can do is lay out all those things that we just listed. At the top, we have principals, we have identity, we have roles. At the bottom, we have these securables. And then let's unroll it. Let's say, like, where is the source of truth? Where's the facade, and what kind of facade? So today, in Polaris already, or from early on, since the invention of Polaris, Polaris had this API called send notification. And the idea here was that even in the absence of pass-through federation, that there would be this idea of federation based on static facades. So we see that in this world, you would explicitly create a catalog, a so-called external catalog to contain your entities. You'd create a namespace, and then you'd use the send notification API to essentially tell Polaris, look, there's a table. It's a remote source of truth, but we won't actually care about that remote source. We'll basically say from the outside, something else, some other tool, some other managed service, will be able to send notifications to tell that static facade when things have changed. And then those static facades can survive on their own to serve requests. So this is sort of the most basic getting started way of doing federation, because it's kind of a catch-all. If nothing else, you can always write your own tool that pushes in state updates. But it's not very user-friendly because you have to have a tool that pushes those state updates. On the other end of the spectrum, you can imagine extending this model to include like a world where, let's say, everything is federated in different ways. So you could have all your identities and even your roles synced to something like Okta or Entra. So you could say that we build a system where principals and principal roles come from your third-party identity provider, maybe defined with just-in-time creation of pass-through facades. You could say that your authorization engine is also remote. It could be something like Apache Ranger. And then your actual securables, your catalogs, your tables, your namespaces might actually be defined in a remote Iceberg catalog. And this should all be able to work together long term, right? You should be able to mix and match any kind of federation under this model. So for now, we are going to just define somewhere where we can get started, but something that adds a lot of value in Apache Polaris. And there's more details in the associated proposal document, but what we're basically working towards is to say that we'll have pass-through facades that are just-in-time created for namespaces and tables. You define a catalog level static facade first, and then everything else is just pass-through and just automatically works. So what this means is the user experience will be that you create a catalog, you say that it's a federated catalog, pointing at a remote. The just-in-time creation sort of gives you the best of both worlds. By creating the entities just in time, we can preserve the existing machinery that performs RBAC, that performs that authorization model. It's also a useful building block towards things like caching functionality or catalog migration scenarios. But because it's just-in-time creation, it has the same ease of use as implicit federation, meaning the user never has to juggle with tables or namespaces or anything. You just link in your catalog and everything should just work. For the MVP, we are going to define, this might be more of a technical nuance, but essentially you would define a connection in terms of a credential, an identity. For now, to get started, you would define your connection configuration with like a system identity that behaves as essentially a super user role into your remote catalog. And then what this allows us to do is to have Apache Polaris still provide its own RBAC system for the principles defined in Polaris, while the federation connection happens as a system identity. So we'll do a demo. I think, and we'll take questions afterwards. I think it's possible the demo will also help answer any questions. So let's do that. I don't know if there's let's take this microphone here. Okay. So, okay, I'll try to make sure you can still hear me. Okay. So to begin with, what we have here is I have Snowflake Open Catalog, which happens to be a managed Iceberg REST catalog. It also happens to be based on Polaris, but as far as our federation is concerned, we don't really care about that. So we have Open Catalog. We have some data already in there. I have S3 open over here on the left-hand side, just so we can look at the files as they come. What we're going to do is we're going to run a local Polaris server. So let's see. So this is all open source. This is also work in progress, but technically anybody can go and git clone and check out my branch and do this yourself as well. So initially, we'll say before we run a local server, let's try to talk to a local server that doesn't exist. So let's say, oops, okay, we're gonna run Polaris command line tool. We're going to use local secrets. So root secret, this is a development credential. So we'll see, like, since I'm running a local development server on local host, we're just going to use development credentials. And right now, since I'm not running any server, we see that the connection failed to connect. And that's expected, right? So this means there's no tricks up my sleeve. It's already, there's no local server yet. So we're coming from a completely fresh, clean slate. So now I'm just going to Gradle run just to start the server. And as soon as we see the iceberg scroll by, okay, I think it scrolled by really quickly there. So the iceberg scrolled by, there's some ASCII, we can take a look at it. So the iceberg means that it's ready to go. So don't worry about the 97%. If you see the ASCII art, you're good to go. So now let's rerun that command we just did. So sure enough, we see there's no catalogs yet, but we also didn't see any error. So that's good. We talked to our local, we managed to talk to our local server. So now we're going to create that catalog facade. So as we see here, the way this works is we're again talking to our local server. We're going to provide a storage configuration. We're going to give it an S3 path. And here we're going to tell it a remote URI. So this is the magic where we tell it, look, this catalog that we're about to create, this instance of a catalog we're going to create, points at this Snowflake Open Catalog. And in there, as you can see, I have my secrets hidden. So we're going to pass in the secrets, and then Polaris will securely store those secrets. Those are the system credentials I talked about that know how to connect to the remote catalog. Now, sorry, I'll just do this again. So let's list the catalogs again. Now we see that we've created an external catalog. You can see how our client secret, client ID are hidden. So they're safely stored securely in Polaris. And we know that in this catalog, it knows to connect to that remote connection, snowflakecomputing.com. Now let's do some things. So right now we haven't created a principal yet. We haven't done any RBAC types of things, but as root we can at least list the namespaces. So we can see that even though we just started a fresh catalog, which would normally be completely empty, when we list the namespaces, and as we do that, we can see how things scroll by in our local server. So it is going to our local server and relaying over to the remote catalog. We see these pre-existing namespaces. So that's good. We already see things that already exist. Now let's create a brand new principal. So here we just used the command line tool to create a new principal, and now we're going to use this principal, which we called Spark Worker. We're going to use it to try to list namespaces. Oh, so we see we're forbidden. We're not allowed to list namespaces. Why is that? It's because we just created it. There's no permissions assigned granted to it yet. So as expected, we can't even list namespaces. Similarly, we can't call get on the namespace either. So now we will fast forward a little bit. You don't need to go through all the RBAC mechanics, but we're going to grant privileges. We're going to create privilege, principal roles, catalog roles, etc. And we're just going to go ahead and grant some privileges to this principal. So so far we've granted everything up to namespace list. So if we list the privileges for this principal, we'll see that, yes, the Spark worker now has namespace list. That means that if we list namespaces, it should succeed. And if we get namespaces, it should fail. So the first one succeeded, it listed namespaces, but then we also see, oh, we don't have load namespace metadata, so it'll still fail. Now, so since we're just doing a demo, so we don't need to worry too much about permissions. So let's just YOLO this and give the big permission, catalog manage content. Now this principal can do everything that we want it to do inside of that catalog. Now we're going to load up Spark. So here we have that Spark credential that we got when we created the principal. We're going to make Spark talk to the local host catalog. And this is Spark just out of the box, right? So this is the Iceberg REST API. There's no special client libraries needed for Polaris. And we're going to spin up a Spark SQL shell. Okay, so now that we're in Spark, we can show namespaces. Sure enough, we should see the pre-existing namespaces. We can create namespace Redmond Meetup, let's say. Okay, so now that we've created that namespace, let's see if it shows up. I refresh, and sure enough, it shows up here. Let's use that namespace Redmond Meetup. Let's create table 1. We'll have a string. And again, let's refresh. And sure enough, that table 1 shows up. If we open this up, we see that call 1 that we just created. And let's refresh S3 now. So let's open. Oh, no. Well, okay. Let's try this. Okay. So Redmond Meetup, table one, metadata. Great, there's metadata available. Let's insert into table one values, right? Hello, Iceberg Meetup. So with federation, this also allows Polaris to perform credential vending. So that's one of the key features of Polaris. It can vend credentials for at a table level, level of scoping of the credentials, so that client libraries don't need to have latent credentials available. So we can select hello Iceberg Meetup. Great. And now if you again, let's refresh S3 and we see that there's new manifest files. If we go into data, we can see that our precious hello Redmond Meetup is stored safely in Parquet. Now, if we want to drop, we can drop table one, purge, and go back up to Duo catalog, and sure enough, there's no more. Our data is safely scrubbed out, and we can also drop the namespace just for completeness. Okay, so we cleaned up after ourselves. We go back to our catalog, and we're ready to run the demo again if we want. So that concludes the demo. Any questions?
So I'm trying to understand, we have a principal role and then we have a catalog role. So what is the principal role then basically containing? Is it just pointers to like the access it has on this catalog only?
Yeah, so the two level, this is a little bit, outside the scope of the federation topic, but in Apache Polaris, principal roles generally feel a little bit more like functional groups, or like let's say business groups. So like maybe you have like developers in your company, and you have managers or finance managers, and then this multiplexes down into catalog roles, which are more convenient to do by sort of data, like physical functions. So you might have sort of like, you'll have like server logs or server logs processor, right? And then that way you have that layer of indirection. Yeah.
Right now, if I understand correctly, right now, the catalog owners have to publish it in Polaris, right? The tables and catalog and this will. Is there any option to mirror it? So I go and say this is my catalog, and Polaris goes and pulls all the information. This is possible.
Yeah, that is so like I meant when I said that the existing Polaris, so that's before all this federation work, right? Like without the work in that branch I just demoed, you would have to push data into Polaris. The what I just demoed actually shows that nothing had to be pushed into Polaris initially, right? Like everything is pulled from the remote. Now there is one layer beyond that, which is in a migration scenario, you might want to proactively pull everything, right? And not just the things that your requests happen to do. And actually, that's an excellent question. I know I hinted at this. We didn't have. I didn't want to take up the time preemptively talking about this, but there is a relationship between federation and migrations, which is to say, what you can do is start to have this architecture that's able to contain these pass-through facades, and maybe be able to do something like if there's logic that knows how to do caching with cache invalidation. There's recent work that adds this idea of table freshness aware table loading, where you can pass in an e tag to determine whether or not like the remote won't have to load the file if you already have the latest version. So there's little tricks, technical tricks, which you can do to make caching efficient. And then once you have that kind of protocol, you can actually build a whole migration layer on top of that, because you could say, okay, let's have the migration layer go discover all the objects, right? And then for all the objects, you'll store the current known versions, and you'll need some kind of cooperative protocol, of course, if you're going to do a migration. But ultimately, the idea would be that it's almost like you could have an rsync kind of a semantic, where you say, look, here's my local, here's my remote. I want to make sure that they're exactly the same. And under the hood, things will have to, exchange hashes and version numbers and things like that just to figure out how to do it. But yes, that can be built on top. So that would come later. Okay. Yeah, so feel free to ping me if you want to chat more, ping me on Slack or anything as well. Always happy to talk more.